Good morning, welcome. The idea behind this session is, as the title suggests, keeping your Java applications secure. My name is Simon Ritter. I'm the Deputy CTO of Azure Systems, and I've been working with Java for, well, quite a long time now, since I started at Sun Microsystems back in February 1996, about the time that JDK 1.0 was released. Now, the whole idea behind this presentation is to talk about the security of the Java runtime. So we're not talking about security in terms of how you write your applications, how you keep the code that you're writing secure and avoiding some of the issues that you might have in terms of preventing people attacking your code. We're talking about the Java runtime itself, the JDK. And so one of the things that we need to understand is that the way that the JDK is being developed, the way that the JDK is being released, and the way that, most importantly, the JDK is being updated has changed. I'm sure everybody already knows about this because it's been around for sort of 3 years now. And we've seen that since JDK 9, we've moved to the idea of a 6-month release cycle. So now we get 2 releases a year. We get March and we get September. And I think we can all agree that this is working very well. We've seen 7 releases in the space of 3 years, which is frankly incredible. But we've seen that the ability to add new features to Java in a controlled way is really working very well. We're seeing many more features come through much more quickly than we ever have done before. And this faster release cycle has also allowed the developers, people like Brian Gertz, people like Mark Reinhold, to introduce this idea of things like modules that are sort of not included as part of the specification, and also preview features, so that we can include a feature, we can play around with it, we can test it, we can see what's going on, and then move it to the product somewhat later on. And that's a really powerful thing to be able to do. So we can make changes before it gets set as part of the standard. So like I say, I think that this whole idea of the release model is working very well. The reason behind this was that the developers wanted to make the development of the JDK itself, OpenJDK, more agile. And we've seen the shift away from the old sort of waterfall model of developing software to agile development is the way that we do things now. And the ability to respond more quickly to changes in requirements, the ability to do more iterative development processes, continuous integration, continuous deployment, all of those types of things is what this is about. So making the OpenJDK as agile as the software you're developing. Now, the way that we do that is by changing some of the ideas behind how new features are included. So we've moved away from having the release driven by the features to having the features only be included if they're ready. And so if a feature isn't quite ready, they don't delay the release, they simply shift the feature to the next release. And again, that seems to be working very well. Now, the important thing is that having a much faster release cycle means that extended support, extended maintenance of releases had to change. And so rather than the old system where Oracle and Sun before them would release updates on a quarterly basis, and they would release them for the current release, plus some overlap for the previous release. And that could be anything from like a year, I think it was about 13 months, all the way up to sort of like 2 years of overlap. That's just not practical when you're doing a 6-month release cycle. What Oracle said then was that they would introduce this idea of long-term support releases. And that way, one release every 3 years would become a long-term extended support release. Now, a very important thing to understand about this is that applies to binary distributions of OpenJDK. It doesn't apply to the OpenJDK projects and the source code itself. So long-term support releases are only about the binary distributions. OpenJDK projects, although obviously they're extended in terms of people continuing to contribute to them, this whole idea of LTS is only about binary distributions. And even that is not defined in any way. Oracle have their way of doing long-term support releases. Amazon have their way of doing it. Adopt OpenJDK have their way of doing it. Azure have their way of doing it. And it's not set in stone as to how that works. To get things started, Oracle decided that JDK 8 because everybody was using it at the time, or almost everybody was using it at the time, they classify that as a long-term support release. And in terms of how long that would be continuing for, they said that the last public update would be January 2019, last year, and that since then, things would change. However, for personal use, if you're sitting at home playing Minecraft, then you can still get updates until the end of 2030. The next long-term support release, as I'm sure everybody here knows, is the JDK 11. And that means that JDK 9, 10, 12, 13, 14, and indeed 15 are what they call feature releases. And that means that they only get updates until the next release from Oracle. Now, very important thing is about updates. So we've talked about long-term support, but what about how we get updates and the availability and so on? Now, as I said, the Oracle JDK has long-term support release versions. So JDK 11, JDK 17, and so on. Most importantly, Oracle changed the license that they use as of JDK 11. Prior to that, they were using the Oracle binary code license. Oracle binary code license said that you could use Java on your laptop, on your desktop, in your data center without charge. The only time that you needed to change the license was if you wanted to use an embedded system or a single purpose machine like a kiosk or a ticket machine. JDK 11 uses the Oracle Technology Network License Agreement, and that has different restrictions in terms of how you can use it. So there are basically 4 situations where you can use the Oracle JDK for free. That's personal use, meaning playing Minecraft at home or personal productivity applications. If you want to use it for development use, you can use it for free. And then the other 2 situations are if it's an Oracle approved product or Oracle Cloud Infrastructure. Other than that, you would require a Java SE subscription in order to get those updates. JDK 8 is a little bit of a strange one because it's sort of half one and half the other. If you've been using JDK 8, then you can continue to use JDK 8 indefinitely for free, but only up to JDK 8 update 202 and earlier. That's the one that came out in January last year. As of April 2019, the update 211, that was released under the same license, the Oracle Technology Network License Agreement, which means you can't deploy that into production without a Java SE subscription. So why is that important? Well, in order to understand that, we need to think a little bit about vulnerabilities. And vulnerabilities are places where software, and that applies to Java, it applies to any other software, exploit to gain action, something you have preventing an application from working in the way that you expect it to work. So how vulnerabilities are classified is based on what we call CVEs and CVSS. CVE, again, I'm sure everybody's kind of heard of this, is the idea of a common vulnerability and exposure. And a CVE basically defines something that can be used to exploit software. So a problem that can be used to gain access to information or to stop an application from working the way you want it to. So denial of service, something like that. You then have a CVSS, and that's a common vulnerability scoring system. So each CVE has a CVSS associated with it. The CVSS is basically broken down into a number of different sort of fields, which have a score as how easy it is to exploit that vulnerability, whether you need physical access to a machine, whether you can do it across a network, all sorts of different things about how that vulnerability can be used. And then we divide that up into various values. So the value that you get from all those different fields gives you a total value that's somewhere between 0.1 and 10. And so we then divide those up and we say, okay, if it's got a score of 0, clearly there's no vulnerability there at all, so that's none. And then based on what value you have beyond that, 0.1 to 3.9 is a low score, 4 to 6.9 is medium, 7 to 8.9 is high, and then 9 to 10 is critical. So those are the ones that really matter. Those are the ones that are going to cause serious problems if people can actually access those. So how important are updates to Java? Well, actually very important. And what I did here was I looked back over the sort of history of the updates all the way back to January of 2017. That was sort of the easiest kind of date to go back to. And I looked at what was the highest CVSS associated with each of those releases, those updates. And what I've done here is I've obviously shown that in terms of the version that was impacted, the date, and the maximum score that we had there. And then I put a line to show you where updates to Oracle JDK 8 stopped. And if you look at that, obviously you'll see that the first update after public update stopped had a CVSS of 9.0. That's a critical vulnerability that affected JDK 8. So if you were running JDK 8 in production, there's a significant vulnerability that could affect your systems. Now, what's interesting about that one is when you dig into the details of it, it's actually only on Windows, and it's as a result of one of the DLLs, the libraries, that are used to build the JDK. So it's not even in the Java code itself. It's in the Windows DLL that's used to build the JDK. And then we can see that since then, we've obviously had a fair number of sort of medium ones. Thankfully, we haven't had any high ones. And in fact, in October, October was quite a light release update. And so there wasn't really anything there. But you can see there's still quite a few in the high scoring range. So it is important to keep your JDK, your platform, up to date if you want to make sure that your applications are as secure as possible. Then I also did another sort of breakdown of this, and I looked at, okay, what's the distribution of CVSS scores across all of the updates? And then this time I went all the way back to January 2015. There's a total of 328 CVEs which have been addressed in updates since then. And as you can see, obviously we've got a small number, reasonable number of lows, got a reasonable number of highs, a few criticals, and I then broke down criticals into the 10.0s, which are the absolute ones that you must fix because it's too easy to exploit otherwise. And then the vast majority are in the medium range. But there's a significant number in the critical range. What's that? 59 critical vulnerabilities that should be addressed over the last 5 years. Now, one of the other things that's important to understand about the JDK is standards conformance. How do you know that what you're getting in terms of a binary distribution matches what the specification says it should be? And so each Java release that we have is defined by a JSR, Java Specification Request. This is developed through the Java community process, and a JSR consists of 3 parts. Firstly, there's the specification itself, and that defines, in the case of the Java SE platform, exactly what goes into the core Java. What do you need to call something Java? You've got a Java virtual machine specification as to the functionality of how to process bytecodes and so on. Then you've got the Java language specification that gives you the syntax of the language that can be compiled into bytecodes. And you've got the core class libraries that need to be there in order to support the runtime. So that's the specification. The second part of the JSR is a reference implementation. And that's essentially a set of source code that shows that the specification can be implemented. You haven't defined something that's impossible to implement. In the case of Java SE, OpenJDK is the reference implementation of that specification. It's open source, you can look at it, you can see how it works. And then the third and very important part is what's called a TCK, a Technology Compatibility Kit. In the case of Java, that's often referred to as the Java Compatibility Kit, and it consists of over 150,000 tests that verify what you've got in terms of a binary for the Java runtime matches the standard defined by that JSR. And it will test all different aspects of the system. It will test the JVM, it will test the core class libraries, all of those different things in order to ensure that everything works in the way that it should do. What's really important about that is it gives you an assurance that the binary you've got matches the standard. And so if you move from one provider of a Java runtime that is TCK tested to another provider of a runtime that's TCK tested, you have a very high level of confidence that your application will run in exactly the same way on both of them, because they both pass the test, they're both equivalent in terms of the functionality. So let's talk a little bit about what we call the Zulu build of OpenJDK, because this is a binary distribution of JDK. What we do at Azul is we take the OpenJDK source code and we create what we call a slightly enhanced build of that. Now, again, very, very important is that even though it is a slightly enhanced build of OpenJDK, it is fully TCK tested, and we ensure that it passed all those tests. So you've got this high level of confidence that if you want to move from a different distribution to Zulu, then there's no need to change any of your application code. There's no need to recompile your code. There's no need to worry about things behaving differently. In terms of providing support for older versions, we actually go all the way back to JDK 6. And so there is an Open JDK 6 project. We use that source code, we build from that, we backport the changes from the current release all the way back to JDK 6. We then also support JDK 7, JDK 8, JDK 11, and in fact JDK 13, because we have something that's slightly different, which I'll talk about in a moment. A couple of other things that we've done in terms of this enhancement is that for JDK 8 specifically, we've seen that lots of people are still using that, and there's a couple of things we thought would be useful to those users. Specifically, flight recorder, so that if you want to use mission control to analyze your runtime, see what's going on with your application, then you can do that. And also TLS 1.3, that was ported, or that was made available in JDK 11. We've then backported that to JDK 8 so that you can use that simply with the command line flag. Again, no command line changes and so on. We have wide platform support, so it's Intel 64-bit Windows, Mac, Linux. Also, for people who might want to use older versions, then it's Intel 32-bit versions of Windows and Linux. And it is very much a drop-in replacement for other JDKs. Now, interesting from a Microsoft perspective is that this is something that we produced originally for Microsoft for the Azure cloud. That was the whole reason for us doing this work. And so if you're using the Azure cloud and you want to run Java applications on that, then the Java distribution that you will get for that will be Zulu. And in fact, all of the cloud infrastructure underneath also uses Zulu where it's using Java. Another thing that's important to understand is about the way that updates are provided. And the way that Oracle do this, and we at Azure batch the same thing, so we do an identical thing, is provide two different versions of each update. And what you get is the first version is what's called the CPU or critical patch update. That's the Oracle terminology. It's a security-only update. So only the security-related patches are included in that. The idea behind this is that if there is a critical vulnerability that needs to be addressed very quickly, you can do some quick testing on your applications, make sure everything starts up and runs. Then you can deploy this into your data center or onto your machines and make sure that you've got the maximum level of security for your applications. The second version is called the PSU, or Patch Set Update, and that's a full update, including security fixes, bug fixes, any minor enhancements for performance, whatever, any other source code changes. What you can then do is you can say, okay, I've deployed the security update, got my system secure. I'll then spend longer testing my applications against the update because there might be some things that have an impact. And then once I'm happy with that, I deploy that into my data center. So that gives you the maximum level of stability. How important is that? Well, it's interesting because if you look at the July 2020 update, that included in the full update, the PSU, there was a fix that fixed a problem, but also actually broke some other things. So it was a significant regression. Things like Hadoop Cluster, Solr, Lucene actually stopped working with update 252. If you'd had access to update 251, the CPU, that didn't include the fix that broke those things. So you could have deployed that. You could have addressed the highest score there, which was an 8.3 CVSS, and then you could have waited for the fix to the fix, which actually took nearly 2 weeks to create. So that's a good reason why you might want to have both the security-only update and the full update. In terms of extended support, as I said, there is no definition of long-term support. It's up to individual providers to what they do for that. So what we do is we make sure that we backport all the bug fixes, all the security patches for our supported OpenJDK releases. In terms of long-term support, what we've said is we'll do 9 years of active, which means 9 years of quarterly updates and any extra updates that need to be provided in between those, and then 2 years of passive support, meaning you can still report problems and we'll provide a fix. And then we've come up with the idea of medium-term support. So for 13 and 15, which are between the long-term support releases, we will provide extended updates to those until 18 months after the next long-term support release. So that'd be 17. That way, if you want to use features from 13 or 14 or 15 or even 12, then you can use those by using either 13 or 15 and deploying those into production. Just to summarize then, since I've got about a minute left, keeping Java applications secure from the point of view of the JDK. So Zulu, builds of OpenJDK, provide you with TCK-tested binaries, updates with a time-defined service level agreement, so you know that you're going to get them within a certain space of time, all security patches, all bug fixes for all updates, both the CPU and the PSU, and 24/7 support issue reporting. So it's about maximum security, maximum stability, maximum flexibility for you as a customer. So that is basically the presentation on that. So I guess since I'm just on 25 minutes past now, if I stop sharing my screen and I go back to there. Okay, so let's see, do we have any questions, comments, anything like that? Oh, yes, Bruno, great, good.
I don't think we have questions.
Okay.
Let me double check here on YouTube. Well, somebody at Zoho tried Zulu. Well done. That's one comment here on YouTube. On the one thing I thought about when I was looking at your, especially the first slides, you had one slide that talked about JDK 8, that up to an update, it's a license, and then another update, Oracle changed the license.
Yes.
But that is, just to clarify, that's specifically for Oracle JDK binaries,
yes.
right? Not Java 8, because I think that's one of the confusions that people continue to have. Oh, Java 8 is not free anymore. Well, it's the Oracle Java 8 binary that is no longer free for production use.
That's right. So I do try to be as careful as I can about making that point. So if you want free binaries, then you can come to our website, and we have Zulu Community Edition, so you can get the Zulu 8 from us. There are other people who can provide that. So there's people like Amazon with Corretto. There's people like Adopt OpenJDK that provide free binaries. There's the SAP machine. Trying to think. Alibaba have Dragonwell. Bellsoft have a free binary as well. So there's the great thing is there's a nice choice of binaries that you can use. So you're not restricted in terms of only one or two. There's lots of different people who are providing versions of Java that you can use.
Yeah. The other thing that is becoming a challenge for many developers, especially in this transition from 8 to 11, and now from 11 to whatever version comes next, is managing multiple JDKs, especially in their developer environments, because one developer at a company is very likely they will be working at not just a single project, but multiple projects. And they may be dealing with a new project, but having to provide maintenance to a system that is already in production. So they have to be switching between JDKs. Are you observing that as well when you talk to your users and customers and developers?
Yes, to some extent. I mean, most people who are deploying into production environments are tending to go with the long-term support releases. So it's either going to be 8 or it's going to be 11, and then 17 when it comes out. There are a number of people who are also following the regular cadence. But one of the things that obviously makes a difference to this is the sort of kind of move to microservices architecture. And so people are deploying into a container, and that makes life a lot simpler because you're not using a centralized JDK instance and then having to worry, is this 11 or is it 8 or is it, whatever. So you just deploy into your container, you use assuming that you're on 9 or later, you use JLink, and you create a runtime that's specific to your application, put it into your container and deploy that. And it just makes life a whole lot simpler. So that's one of the things I am seeing people do a lot.